need to give your AI tools human-friendly names and safety indicators without cluttering your function definitions. We'll use FastMCP's annotation system to add metadata like display titles and read-only hints to our calculator tool, showing how to make tools more user-friendly while keeping the implementation clean. The pattern demonstrates how to communicate tool behavior to client applications through standardized metadata hints. At MCP, tool. Annotations equals. Title, calculate sum. Read-only hint, true. Open world hint, false. Def calculate sum A, float B, float, float. Add two numbers together. Return a plus B. This demonstrates the AI tool integration pattern, where Python functions become callable endpoints for language models through declarative decorators. The @MCP tool decorator transforms a standard function into an AI-accessible capability, complete with automatic schema generation from type hints and docstrings. What makes this distinctive is the seamless bridge between human-readable Python and machine-consumable tool definitions without requiring manual API boilerplate. The pattern works by leveraging Python's decorator system to separate interface definition from implementation. FastMCP introspects the decorated function at runtime, extracting parameter types, return annotations, and documentation to create a self-describing tool schema. This declarative approach means your function remains pure business logic, while the framework handles validation, transport, and protocol compliance automatically. This approach solves the problem of exposing backend logic to AI systems without writing custom API layers. It's particularly valuable for AI agent development, where you need to provide tools that are both type-safe for developers and self-documenting for models. The trade-off is framework coupling, but the benefit is rapid iteration. You can modify tool behavior by changing Python functions, not API contracts. Let's break it down line by line. At MCP, tool. Annotations equals. This starts the tool registration with metadata annotations. The annotations dictionary defines UI behavior and capabilities, like whether the tool can modify state or requires read-only access. This is FastMCP's standard pattern for declaring tool characteristics that the AI and front-end will respect. Title, calculate sum. This sets the human-readable name for the tool in AI interfaces. Without it, the function name calculateSum would be shown to users, but this ensures the UI displays calculateSum instead. Read-only hint, true. This flag marks the tool as read-only in the AI interface, preventing any state modifications. Critical for tools that only compute or retrieve data, eliminating unintended side effects. Open world hint, false. This disables open world execution, restricting the tool to closed world operation only. Prevents the AI from inventing new parameters or behaviors beyond the defined schema, ensuring strict type safety and predictable behavior. Critical for production tools where unexpected inputs could cause failures. This closing brace terminates the calculateSum function definition, completing the decorator application and function body. It finalizes the tool registration with FastMCP, making the function callable by AI models with the specified schema and metadata. This closing parenthesis terminates the @MCP tool decorator declaration, finalizing the function's registration as an AI callable tool. Without it, the decorator would remain incomplete, preventing FastMCP from properly exposing the function to models. Def calculate sum A, float B, float, float. This defines an AI callable function with strict type hints. The float, parameters, and return type enforce numeric inputs, while the decorator exposes this as a tool in FastMCP's schema. Type hints become the tool's contract, preventing invalid calls at runtime. Add two numbers together. This docstring defines the tool's purpose for AI models. FastMCP converts it into natural language documentation that appears in tool descriptions, ensuring clear usage instructions for both developers and AI callers. Return a +B. This implements the core logic of the AI callable tool. The simple addition operation demonstrates the minimal viable function body, while the decorator and type hints handle all AI integration complexity. FastMCP automatically converts this return value into the tool's response payload. FastMCP output schema pattern. The @MCP tool Decorator automatically generates JSON schemas from Python type hints, creating structured outputs that AI clients can validate and consume without manual schema definitions. Primitive return types get wrapped in a result object automatically, which can surprise developers expecting raw values in the response. This pattern eliminates schema boilerplate while maintaining strict type safety between server and client.
The schema that disappears from your code reappears in every client.